He was SG2 at Bank of America. So he has a very good background of both data engineering as well as backend development in Scala, as he has already also worked as a Spark Scala developer in another company, and he will tell more about himself when he will speak. Like he has overall of 7 years of experience, and today he will present on building concurrent and distributed systems using Scala. So yes, Ayush, over to you.
Hi everyone. So this is Ayush. As yeah, Siddharth gave a brief introduction about me, I'll start introducing myself first by myself. I'd like to share my screen first. So, yeah, my name is Ayush Gour. I am currently working as a senior software engineer with one of the fintech fast-growing company called Bankify. I have got total, 8+ years of experience in the IT background, and for the last 5 to 6 years, I have been working with Scala and development ecosystem with one of the fastest fintech company present there in the European system. And previously, I have also worked with Bank of America, worked there as a SD2 as a Scala developer. I was working extensively there also working with the Scala-based backend microservices development, and it was also like kind of fintech, completely fintech project. So overall, I have got very extensive and rich experience working with fintech applications and fintech background and domains. That's about it. Me. Apart from my experience, I have got. I'm also holding MTech degree in as per the education wise, and that's about me. Yeah. First of all, I would like to know about people who have joined. Like, may I know how many years of experience people have joined? They are beginner or they are senior, and how many of them are more than 3 years of experience? Um, yeah, you can
Hey,
just speak about things. Yeah.
yeah, didn't find a hand to raise. This is Abhishek. I have 7 years of experience, mostly
Sounds
as a
great.
data engineer.
So mostly I can judge like we have a mixed crowd. I think we have experienced developers as well as we have those who have just started. So yeah, I can see it's a mixed crowd. Yeah, you can take it like that, I think.
Perfect. I'll have so basically I'll have a mix audience so that I'll just have a mindset about how I'll go proceed and ahead with that. Okay, that sounds great. So yeah, that's about me. I have been working for the last 7+ years of experience with Scala, so I think I'll be able to share my experience with how to build distributed and concurrent application in a large production based domains, and how we'll be able to deploy, how we could be able to develop the such application, what are the pros and cons we have experienced, and how we'll be going to just tackle each and every problems that we'll be having come around or under this umbrella. Okay. So let's talk about building concurrent distributed systems using Scala. So first of all, I would like to know about how many, like, did you anyone got a chance building any kind of concurrent and distributed application? Most probably, these applications are existed in the big data or database environments, right? Anyone have got basic experience about it? Like,
Yeah, I worked with big data systems I mean, using mainly Python and Haskell.
okay. Oh wow, that's good. That sounds great.
Yeah, that was done at Just in Bangalore.
Oh, that sounds good. So yeah, basically, like, if we are talking about the building concurrent and distributed systems, basically there are fundamental, fundamental key points that we need to understand before jumping into that. Distributed system, basically, just in a layman terms, we can just say that it is just a network of independent computers, or maybe nodes or servers that works together for like they works together as a single unit for accomplishing any kind of task, right? So for building such computers, we are really interested into utilizing the each and every servers and nodes capabilities to solve any problems in a very faster and efficient manner. There are key characters for distributed system. We can just start with scalability. So any distributed system should support scalability. Mm, Scalability is the key measure point for a system to just simply this is the characteristic which simply allows a system to grow by adding more resources like nodes or servers, basically which helps managing the increasing the overall workload that we can handle in a scalable manner. Second characteristic will be fault tolerance. Basically, like since a single machine is very critical to handle a high load of communication, or how high load of any kind of business logic that is needed to be processed. So basically, like uh, we just needed a system where a single machine is not a independent machine which is whole and solo of a whole application. We'll be having a different set of machine which will be connected together, so that we'll be able to handle the failures in one node. If it is there, then we will be able to easily manage that, and we'll isolate that particular failed node, and we'll be able to isolate the whole working system into different chunks, right? We should be also the system should also able to support the resource sharing, where different nodes can share processing powers, where a big chunk of task can be divided or split into nodes, and they can be work together to just share the nodes and share the processing task among others workstations, and we'll be able to solve them. So basically, these are the basic characteristic for building the concurrent and distributed system. Any system that we are saying it is a concurrent distributed system. These are the basic characteristics should be there for for a system to support these, right? So we can just take an example where let's suppose just take an example of real time banking, right? So everyone uses simply a multiple ATM machines, right? So we are having machines, ATM cards. We are having people ATMs which are spread together in a different cities, different countries. But each and every ATM communicates internally with the central banking system, right, to verify all the accounts and all the details of the user. And then, even though the transaction occur in different location, different time, I think system is able to serve each and every user in a very efficient manner, right? So basically, this is the recent and this is the real-time example of distributed concurrent application that we already know about, right? So let's jump into the another thing that is the hot topic for this today's talk is Scala, right? So basically, like to achieve this kind of mechanism, we are having a lot of other applications. We are also having a lot of other programming languages that we can use. But why Scala? Definitely, this is the hot question that everybody thinks about. That why Scala is in a why when building a distributed concurrent application, why we'll be using Scala, right? So basically, like there are different programming languages have their different approaches to solve any problem. Let's dive into why Scala is such an excellent choice when building concurrent and distributed application. First of all, I would like to let you know about that Scala is basically, as we already know, that it is a blend of object-oriented programming and functional programming paradigm. So basically, this is the hybrid approach which gives us the best of the both world, where any problem can be solved. We can just get the leverages of object-oriented practices to solve a problem, along with there are certain areas where we can use functional programming, which is very important for us when building the function distributed system. Basically, Scala gives us a very concise, expressive syntax paired with the strong support of functional paradigms, principles like immutability and pure functions. It's a functional style where we just compose the functions by calling another function and return the functions to solve any problem. So it's a functional driven application that we can just use for this, right? So when we write any kind of application that avoids mutable state, or inherently reduces bugs, and much, make it very easier to reason about any concurrent operation, what's going on behind the scene. So Scala's standard libraries comes with powerful inbuilt abstractions like futures and promises, where we can use we can, which usually allows us to write asynchronous code without getting entangled in low level thread managements, which will be very important for us for concurrency. And these basically features simplifies the execution of parallelism, like parallelism task that we want to execute one by one, not one by one. It's a synchronous process. Whenever we want to achieve asynchronicity of an execution of any kind of program, these are the low level APIs that we can use. That Scala basically provides seamless execution and seamless support for using that. We can, moreover, we already know about that because Scala runs on a JVM, right? We will get us interoperability with the vast ecosystem, since Java already having a lot of libraries and framework. If any problem that really needs to be solved with the high level of uh, abstraction, definitely we can make the use of JVM libraries also for that. So seamless integration can be also implemented there itself, right? Apart from that, we are also having different libraries which are already available. So let's suppose we are talking about future and promises. Future and promises are the existing API which is Scala natively support. Third one, second one is we are also having parallel collections by basically we are Scala already have a lot of connection parallel collections that we can simply use for achieving concurrency for any kind of task. We are also having the actor based model, which is one of the highest, I would say, highest achievable model that Scala has. And there are a lot of industries like Bank of America, Bankify, and all these companies are highly using actor based model to communicate in a message passing manner for achieving the concurrency for any building softwares. So we are also having additional libraries like Akka Streams, type level ecosystem, where we use cats and cats effects. And we also have a Zio ecosystem, where it also have a certain list of libraries which we can use for achieving the concurrency and distributed system uh, characteristic for building any softwares. Let's talk about the Akka toolkit. Basically, why I'm directly jumping on Akka, because Akka is basically a toolkit that has become, the widely spread. I would say it's just a synonym of building a concurrent and distributed application on JVM. So basically, at the core, Akka is just an actor model. Okay, in this model, each actor encapsulates its own state and behavior. So in order to interact with the other processes and other threads, they simply talk. Each and every talk usually happens via sending the messages. And the design simply actor models design basically eliminates the need of modern problems like locking mechanism, race condition, avoiding the shared mutable states, right, etc. So basically, it's greatly reduced the risk of race condition via using the actor model, because we simply get rid of the low-level API, low-level management of thread. Actor basically just an unit of computation which takes care of each and everything. It's just an abstraction of it, right? One of the most significant advantage of using Akka is simply like ability to scale. Actors are basically incredibly lightweighted. First of all, meaning that means you can just run thousands or even millions of actors concurrently, far beyond what traditional, I would say, Java-based threads can support. With location transparency, actors can also communicate seamlessly, regardless of whether they are residing on the same machine, or distributed among different nodes and machines, or across a different network, right? This is crucial when building the distributed application system. Actor model was especially designed for implementing and solving such problems, right? Akka basically also provides a clustering capabilities. It has a lot of different uh, low level or high level APIs that we can use for for achieving a characteristic of concurrency and distributed systems, right? So basically, we just want to understand that when solving a problem, which is basically where we want to achieve a concurrency where millions of users can solve any problem, and they can just uh, reach out to any system, and they can just do their operation independently, and regardless of their location, regardless of their timing, I think they should be able to interact with the system seamlessly. In such case, we are definitely we can use akka toolkit, which is going to be very useful for us for building the toolkit and just solving the problem based on this.
I think
Basically,
Ayush, like we can discuss few questions like as we discussed also. So Abhishek is asking, Abhishek, you can unmute and ask.
Yeah. Yeah, thanks for the overview, Ayush. How is fault tolerance implemented? I may be jumping a bit ahead. You might have it in the slides in further slides, but if you can give a brief of fault tolerance in Akka.
yeah, sure. So basically, when we are using akka inherently support fault tolerance. This is one of the characteristic of it, right? So basically, it also support inherently a fault tolerance mechanism where particular where we'll not be depending upon completely on a particular node. Let's suppose we are working in a distributed environment, right? So what will happen that we will be able to isolate. As I said, that Akka is actor-based model, right? So Akka, each and every actor in Akka operates independently. That means that it encapsulates its own state and behavior. That means this gives us the isolation. Okay, that means if one actor fails, right, the failure is completely contained, and it does not directly affect the other model, or the whole system, right? So if one actor is somehow is being crashed, right, we just simply say that okay, let it crash, right? Rather than attempting to handle each and every possible error internally, we will simply say that akka usually will say that it just let it crash each and every model or each and every node if they are being crashed automatically. uh, we will be just each and every actor is independently operating, so that failure will not be affecting the whole system or any kind of process, so that we'll be able to achieve the fault tolerance. That means we'll not be able to shut down the whole system just because of one node which somehow gets down, right? So there are certain there are certain strategies that we can implement while developing distributed application for achieving the fault tolerance. That means uh, you know restarting the node. So let's suppose one node is somehow got failed. We can apply some sort of strategies, like we can restart that particular actor. Okay, or if somehow it got failed, we can just create other actors. So there is a supervisor mechanism where we can just write a code in such a manner where supervise actor, we can restart the actor, can resume the actor, can stop the actor, or terminate the actor completely if it got failed, and it can assign the whole task into another actor, right? So there are certain structure or strategies that we can implement to really tackle the fault tolerance you know uh, uh, behavior in our system, right? Basically, why we are using akka, because the actor model forces actors to be completely isolated when it comes to sharing the state and behavior of any system. That's how we can simply achieve it.
Okay, got it. Thanks.
Yeah,
Great.
well, I have a question if you guys don't mind. Like, I'm seeing parallels to, if you're familiar with Erlang's Beam, is this how this somehow works? Where you spawn like multiple lightweight processes, like millions of them, and if one of them goes down, you essentially have something like, is that a good, what do you call it, a tree to build into? Is that a good mental image to have? So where we can spawn millions of different actors, and then in the event like one of them fails or one of them is somehow like in a deadlock position, one can simply just destroy it and quickly and just efficiently like lightweight processes essentially, right? Is that a good
Right.
mental image to have?
Yeah, correct. So
Thank you.
actor model is not completely limited to Scala. basically it's just a practices that any system, any programming languages can implement it. Most probably, Scala is the programming language which is leveraging all the facilities and all the benefits of actor model. Therefore, we are using Akka. We with Scala with Akka, definitely actor model isolates the state and behavior of each and every actor. So this particular thing usually isolates the whole system into different chunks, right? So let's suppose one chunk is really getting failed, right? We are having some sort of strategies, so we can just implement those strategies to handle fault tolerance. So let's suppose we want to terminate as soon as any actor gets failed, we just want to terminate that particular actor. So we can implement that any actor which is holding any kind of state and behavior of an application or execution business logic, if it gets fails, we'll just terminate that particular actor and we'll just reproduce another one, and the same task will be assigned to it, right? So in that way, systems, the whole business logic will be executed not only via single actor model or actor or thread, rather than it will be propagated or it will be assigned to different models also, or different actors also, so that we'll be able to attain the fault tolerance. Even though one actor gets failed, the same amount of execution will be handled by another actor. So yeah, you are correct.
I
Erlang
see.
Erlang is
Well, thank you
also,
for explaining this to me. It was very much
yeah,
helpful. Thank you.
perfect. So yeah,
I think,
basically, it's a, yeah.
hmm. Yeah, continue. If you were saying something, yeah, please go. You can.
And I think I was just saying that it's just a framework. If we Each and every application will have their own pros and cons, and there will be different strategies they want to implement, right? It is just a toolkit through which you can just implement your whole application in such a manner where a specific problem can be solved with a different set of solutions, right? And we can implement that. It's just that this toolkit will have all the kind of leverages that we want to use. We want to work with the cluster, we'll be having Akka cluster applications. If we want to achieve just in the API communication, we'll be having Akka HTTP. There are different toolkits where we can just pick particular toolkits to solve our problem. That's it.
Yeah. So, do you want to complete your slide or you want to take more questions for now?
Yeah, if somebody wants to have some more questions,
There
then
are, I think there are questions in chat. I can say it, like you can keep the slides on. Vipul, do you want to ask or I can say it for you? I think Vipul's on mute only. So Vipul is asking that with supervisor strategies, have capability to restart actor or to start from the previous state. Uh, okay, so I think no, it was not a question. Sorry. So next we have Abhishek only. He's asking, is the actor state stored in persistent storage? If so, is the state updated asynchronously at regular intervals?
Yeah. So actors usually store their state in a temporary manner, right? Definitely, if we want to store the persistence, we'll be having Akka persistence. Akka persistence, again, it's one of the application, one of the API which Akka as a framework provides, right? So basically, we can use Akka persistence for to just ensure that the Akka state survives the crashes. Let's suppose if some actor gets crashed, right? The system will get system will just restart, or we can just terminate the whole actor and we can start the operation where we left it, right? So persistent actor, basically, instead of storing the entire state, Akka usually uses the event sourcing. There's a event sourcing where only state changing events are persisted. Let's suppose the state of a particular data is changing, we only store that, right? We are not holding the whole particular state of the data, right? So for Akka persistence, storing the Akka actor state, there is a Akka persistence library that we can use. So when the actor restart, it usually replace the stored event to restructure its state. Let's suppose some state got failed, right? it will again restart the actor with the previous state where it was left, right, or where it was failed. So with using that akka persistent, we can really start the actor from where it got failed, right? For persistent storage also, let's suppose for persistence we'll be needed some storage because these events and snapshot needs to be stored somewhere, right? So for that we can leverage this, RDBMS. Like currently we are using Cassandra and MongoDB for storing the state for the persistence. We can also store these persistent data into Kafka topics. We can also use them in memory purpose, but it's not useful. So most of the time for the persistence, for event persistent snapshot storage, we most of the time uses external databases to store the data state, which we can use.
Thanks, Ayush. That clarifies a lot.
So also we have like Makran asking like as we know that okay, so you want to ask, you can ask here.
Yeah, thanks, Siddharth. Hey, hi, Ayush. My name is
Right.
Makaran. So a couple of years back, Akka moved from the Apache license to BSL. It
Yeah.
was a big event, especially for bigger companies, because for smaller enterprises with, I think, limited revenue, there was no change. But for bigger companies, and especially for production deployment, now they have to pay a significant amount. And people I know, at least for newer projects, there is some reluctance when it comes to using Akka for the new projects. Older ones, yes, there are discussions for migration or maybe to continue and just pay up the cost instead of moving. Uh, what did you do? Means, are you still using the older versions? Because with that, you don't have to pay anything. To upgrade, yes, you do. Uh,
Yeah.
Just along with it also, also in the answer, just accommodate. How do you see Pico as? Like, do you think Pico can be a open source substitute for Akka forever, or do you think it will depreciate within the years?
Yeah, correct. So I think that I have got a real-time hands-on experience working with doing migration and also keeping up with the Akka. So when I was working with Bank of America, basically like before that we got to know that business source licensing is only applicable for those companies which are making over 25 million. I correct me if I'm wrong, right? I think so.
yeah, yeah,
So let's suppose when I was working with Bank of America, they don't want to use the Akka anymore in their production, right? So I think 2020 22, I think before that only like in 2022 itself, we migrated the whole code into Paco, right? What we understood that we understood that we just thought about why Paco, because Paco is again another Akka, I would say, right? It's just that Akka license free Akka, I would say, right? So when I did the migration, the whole things was same. Like when you are using actor model and everything, right? It's just a import, just an import, right? Instead of using importing the specific APIs from Akka, you will be importing the same from org.apache.peco. Okay, and there are will be like I would say in my experience, I could able to migrate 3 to 4 microservices in just 2 months, right? From Akka to Peco with full-fledged testing, right? So basically, if we want to stick with open source, the Paco is the only prominent option that we want to use, okay, and uh, which will be painless, I would say. Why? Because it's just a fork of Akka, right? Basically, all the primitives and all the basic functionalities are being still supported by Paco, and all the things can be used in Paco itself, right? So basically, I would say if you want to stick with open source, definitely I would encourage to use Paco. It will not be a big pen. It will be just as same as Akka that you were using, but it's a new version with free. Okay. We can also like we also came across to this where we were just we just wanted to use actor we just wanted to use akka in order to leverage the concurrency and distribution characteristic of it, but we somehow got to know that there are different applications. So for where currently I'm working, that is Bankify, we decided that we don't want to move ahead with akka. So basically for newer microservices that we are using, which are real-time based, I think we have shifted to Rust. So I think you might have heard about Rust, where
Yep.
we are using Actix. Actix is just again a framework like Akka, which is high performance and actor system can be implemented using Rust, right? So moving forward, my company's decision was to stick with Akka. When it comes to existing production based companies, we'll be able to pay them. But moving forward, when we want to achieve the same level of performance, we definitely will not be using Akka. We'll be using Actic Web, which is provided by
I
Rust.
see.
This is what I got, right?
But the problem is like what I'm thinking is like Pecco will be is a fork of Akka, right? So it'll be downstream. So all the changes that will be in the Akka, like Pecco maintainers and stuff, will have to like deal with this. So you'll have to like constantly work downstream, and from my experience, it's a painful thing. So how do you see that happening, and how would they handle it, and what does it mean?
Definitely, first of all, we should be thanking about all the thanks to all the open source contributor who are actively doing and contributing in the Paco ecosystem, right? They are trying to make it as competent as Akka was there and completely existed right now. But yeah, Apache Paco is fully open source fork of Akka, basically just maintained under the Apache license. So if we want to really stick with Akka based model, definitely Paco will be the long term runner for that, right? It is fully integrated and fully featured with Akka. All the features will be available in the Paco, definitely. Akka Paco, you will be having persistence API, you will be having distributed applications, sharding and all the kind of HTTP, Paco HTTP, and all the kind of APIs you'll be able to find, and they are well integrated with the production based system. So you cannot avoid Paco because it's really a complete replacement of Akka. Definitely, Akka is really moving fast with the new implementation like LLM, large language model integration. Okay, native support for the new commercial based applications that are not being supported by Paco, but for solving real world problem solving or existing systems that they want to migrate and get away from the pricing, definitely Paco is the open source is the library that you can really trust on. Because Bank of America, I would say, Morgan Stanley, one of my friend also got some insights from me for migrating from their Akka to Paco. He was from, I would say, he was from, yeah, JP Morgan Chase, right? And in Bankify also, some of the microservices are being migrated from Akka HTTP to Paco HTTP, right? So yeah, Paco is being used, and people they want to use open source. Definitely, Akka is the 100% alternative for
Uh,
Paco
do
is the
you
100.
I
uh,
see.
do you
I
see
see.
like other effect, like obviously no doubt about it that Akka is the most robust out there, but apart from that, the new emerging Scala ecosystem that we are having these days, like Zio and Cats, like how do
Mhm.
you see them? Like do you see them mature enough for companies to replace Akka with? Or you think it's not like full-fledged yet, and there are some use cases where they can be used, but like for example, as far as I know, like Zio do provide a lot of clients and do provide a lot of things, but a lot of connectors are not still missing in it, so people have to implement it on by their own. So how do you think, are they mature enough to be used in production in big companies?
They are fully matured, I would say. In Bankify, we are completely using type level system. So when communicating microservices via API, we are using HTTP 4S. For concurrency, we are using cats and cats effects API, low level APIs that we are supporting. We are able to process millions of transactions in seconds via using type level system ecosystem only. These are completely 100% productionized, and these are real time values that we are getting out of them, right? So we cannot really question about these. The question comes with the kind of competency. So let's suppose if we want to find a resource for a Akka, definitely we'll be having a little bit more resources to hire, right? When it comes to implementing or achieving the same sort of solution via libraries like Zio library or cats or cats effects or type level ecosystem. Definitely lot of education, lot of low level or it's functional programming paradigms, lot of higher candidate types, f types, and lot of things that you want to understand in order to achieve the parallel and comparable performance with akka, right? So definitely they are mature enough. They are, it's just that they are purely functional programming libraries. So for solving the problems without using functional programming, the Akka and Paco are the solution. When we want to gain the fine grain control over the low level resources, definitely we can use uh, you know Zio or the type
Cats.
level system type systems. They are
Mm.
100% productionized, and I would say you must have heard about Swissborg. Swissborg.
Yeah, yeah. Swissborg,
So
very
the
good. Mm.
Swissborgs are the real-time example where they are completely fully integrated with the functional programming libraries like type level. So they are the live example for us, which are completely productionized, right? So basically, if our application is heavily rely on the Akka actors, right, definitely Paco is the solution for that. We want to restructure the whole application from scratch. I think it will be a very big pain when when migrating the same application from Akka to type level or Zero ecosystem. It would really require a very senior resource who really understand a lot of things about functional programming. At the same time, the production development speed will be also decreased. So yeah, it's totally up to the company's policies, right? I would say.
Mm. But for example, if a company is starting a new project, like and they want to integrate Scala only, in the so do you recommend them because rather than opt out of Pico and utilize is Zio or for example Cats, would you say that, or you still think no, in upcoming years still uh, these Cats or Zio are yet to be get fine-tuned and Pico is already very much robust in itself. So what will you say? A newer project should be in Pico or should be in C or Cats?
So it totally depends upon the project. If the company is starting with the new project and if we want to really opt for the choices between ZIO, CATS or like this, right? We can just, there are certain lists that we need to check out, right? First of all, if we want to use ZIO, right? You want, in that case, you want a really pure functional programming approach, right? So if you want to really, if your goals are clear, definitely you want to achieve something via pure functional programming construct, you will be using Zero. If you want your application to be really high performance and high performance with the lightweighted concurrency using fibers or low level fine grain control over your resources, which are actually faster than Akka actors, definitely you will be using Zio, right? Zero. You will be, if you want to if you want to prefer a structured concurrency over an actor model, or let's suppose you don't want to build into the cluster kind of you don't want to integrate your application in a cluster driven application via, rather than you want your application to be performant enough to manage the resources of multiple threads, right, or multiple nodes. Definitely you will be using ZIO type level in that case, right? So definitely the application development time will be taken much more as compared to using Akka. And if so, yeah, these are the main points that we want to use. Whereas if we want to use the Akka Paco, we want to usually, we want to visualize that the project requires event sourcing, or I would say we want to, we want to store the state of a data or be of an actor, so that we'll be able to just make sure that things are changing and we are able to efficiently capturing those, right? If our application does not need to be very high performant in real time uh, uh, scenarios handling, definitely in that case we'll be able to use Akka. If we have a Scala team which is not mature enough to really deal with Scala applications semantics, definitely we'll be using Akka ecosystem for that. For the large scale or mid-level scale distributed system, definitely it is best for using Akka. If we want to really implement the design patterns like event driven architecture that requires actor messaging passing construct, definitely we'll be using in that case Akka, right? So totally depending upon the kind of goal that we have, right? It's completely if we are using ZIO ecosystem or type level ecosystem, will be definitely going to be the best choice when it comes to performance, scalability, and functional programming implementation. But if our project requires architecture like event sourcing, clustering, then Peco and Akka is the best choice for open source APIs or project that is available for us to use. Right? So it also depends upon the resources and the developers which are comfortable to do the development. For the beginner people, definitely Paco and Akka. For senior and mature people, and the application is really needs to be performant, scalable, and real time execution. Definitely, we'll be opting for ZIO and the type level ecosystem for that.
Hmm. Okay. So, any questions? Anyone else or anything if they want to express their personal experience or
Yeah, I just want to ask few questions with my advice with my audience that if anybody have worked with microservices, which are the main building blocks for any application nowadays
I think everyone must have at some point.
at some point.
Yeah.
How many people aware about the microservices communication? Like how multiple microservices, let's suppose there are 10 microservices, how they are communicating to each other, what are the ways how we can implement those solution and how the microservices are being communicated together. Anybody would like to share their experience?
I mean through some interface was it depends upon which interface.
So, yes, Ayush. So it's basically depends on how we are actually using. We can communicate via REST APIs. Is maybe depend or majorly if there is a within services communication we have some Node services, Python, and Scala services. Okay, so we can use REST endpoints, and we may prefer within Scala, we can prefer Kafka, Kinesis, or any other. Okay, so it depends on the requirement or how we actually define our system.
Mhm. Okay, got it. Got it. So basically, like, microservices communication, I think these are the very important thing nowadays because whenever you went through any kind of interviews, definitely people usually stress upon the design patterns and how the microservices are being developed and how they are communicating and how the things you can be able to build, right? So let's suppose nowadays when people are getting interviewed, right? There are a few things that they need to that interviewer is really interested upon, right? That how can you design a microservices for handling a particular task, right? How the communication pattern will be there, right? What are the tools and technology you will be interested to use, and how how the whole design will be there for solving a big distributed system, right? So I think for that I think I came across to my own experiences. Most of the microservices are needs to be developed in a asynchronous manner communication, right? So let's suppose asynchronicity when it comes to microservices development, that it really decouples each and every services using operating on a message or an event independently. Okay, and microservices can also publish their own events, and they can talk via REST APIs. They can also talk via message brokers and Kafka topics, PubSub models, and other things, right? So communication patterns really plays a huge role. In my companies, I am right now using request and response via HTTP applications communications. I have also used with PubSub models where we have leveraged Kafka based on event-driven architecture where services publishes their own events without knowing that which service is going to be consuming those particular events, and subscriber basically reacts on those events. They just take the events, apply some sort of business transformation logic and all the things, right? They can also apply some sort of caching and other workflows that they want to use, right? And they can just again either store the data in the persistent, and they can just pass the same data in the downstream, right? So when really building the applications, microservices communications are really important. System design, when we are designing any kind of applications, services, there has to be a best practices like service discovery, where microservices can scale dynamically as need of the system, right? There should be a API, there should be a API gateway which will be completely handling and act as a single entry point of each and every whole system, right? Which will be responsible for routing the request, okay, and will be just taking care of each and every aspect load balancing and security policies, and all these things we can implement at a API gateway layer also. So there are different practices that we want to really keep in mind. And when really preparing for the interviews, these are the basic points nowadays are being triggered and being asked by the interviewers. So yeah, if somebody is really preparing for the interviews, please stick with these points also nowadays, right? So yeah, that's about it. Uh, if anybody will have more questions, then
So
we'll.
so also like I would like it like if you can scroll down the previous slide and where you wrote the benefit of using Scala. Uh, can you maybe like stress upon how Scala the how using Scala like we can enhance the type safety.
Using Scala, yeah, type safety, definitely. So so basically, Scala itself is a type safe languages where each and every type is really each and every variable, or each and every uh, any single point of thing that is written on the Scala languages, it has some sort of type. That means basically, Scala is a statically typed language, right? That means it will be checking each and every time the type will be checked out at compile time itself, right? Which will be very useful for runtime, runtime errors, like we might have used Python, where we won't get to know about the compile time errors at the compile time, because we will be able to we'll be running those calculation at runtime, and at runtime itself we'll be able to get to know that this is the error, there's some type mismatch or something like that, right? The type inference and static types usually the inherent characteristic of a Scala, which usually gives us a type safety, where each and every value should have its type, which will be checked at compile time itself, right? If we want to stick with this advanced level types, right, we will be having we'll be having features like seal traits, we'll be having enums, right? For exhaustive pattern matching on the types. We want to really we'll have a type constraint and context for checking out the type, whether they are matching a particular type for solving a problem or not, right? So basically, at its core, type safety means that programming program is protected from the type errors, right? So when each and every value will have its own type, will be able to check them at compile time itself. Basically, we'll not be facing any kind of issues when it comes to type safety when writing a core type safe programs. At the same time, with Scala, there are features like let's suppose you want to use a string, right? So let's suppose a particular type which is having a string, right? So we can just for a strong type safety, instead of using simple string, we can just simply assign a type that is non-empty string. That means non-empty string is a type which is again is which gives us the 100% guarantee for a type safety, which is the low level type safety practices that we use. So at our application, we don't use a string, we use non-empty string, where string will always have some value. If we want to have an empty string, we'll just wrap them into the optional, so that, and we define them, we give them the default value as empty string. Okay. If any kind of value will be there, we will be guaranteed that there will not be any type error. This will always have particular value, right? So these are the basic entities, abstract data types that we can use for achieving more fine-grained type safety on a particular applications. We are also having type classes, which will be really enforcing us to stick with the types to achieve the type safeties for a type level errors, right? There are a lot of things that we can use, but yeah, that's about it.
Okay. I think Abhishek has one question. Abhishek, you can ask.
Yeah, thanks for the clarification, Ayush. You mentioned that you are currently working with Rust and its framework for developing microservice.
Yeah. So my current application, what we are doing, we are using OCR. So object character recognition is something that we want to achieve, that we wanted to achieve, right? Therefore, we were just getting the invoices uploaded by the user. Okay, it's a PDF or image of invoices, right? We wanted to achieve the real time text extraction out of PDF and image, right? And extract a set of extract a set of fields values that are presented in the documentation or the uploaded file, right? So it is basically a real time application or problem that we wanted to solve. There are application and libraries which are already available in Rust. So we moved to Rust. We use active webs. We created a RESTful endpoint which is responsible for taking the invoice file as a form data type. Okay, we are using LLMs inside it, where open source LLM called
Oh,
Llama 3.2. We are using that, and we are just extracting the whole data out of that image in a real time, passing it to LLM. LLM is really understanding because we have already set the context to LLM that these are the fields out of any data you need to fetch if they are available. So we extract the data and we create the JSON, and at that particular endpoint, which is written in Rust using ActiveWeb, we get the JSON out of it. Then that JSON we consume and we just display to the user that these are the fields that you uploaded and whether you want to make the payment for this invoice or not. So these are the basic practices that we use for the real-time application and real-time fast performance. We opted for Rust and LLMs. So we integrated Rust with LLMs for solving OCR based problem. So that was my experience working with Rust recently.
And what do you think about future of Scala in general? Because there is a lot of buzz around teams switching towards Rust because it has similar properties to Scala, like a strong type system along with memory management, which is not there in Scala. It has garbage collectors. So, what do you think about future of Scala?
Future of Scala, I would say for the future Scala is completely safe because most of the companies, even though these Rust is already there, Rust has been there for the long time, right? And Bank of America, Bankify, all the microservices that we are using that are still, and then we are developing, we are completely 100% stick with the Scala itself because solving our problem, it's totally aligned with also Scala's I would say all the kind of benefits that we can get. Okay, Rust, I would say Rust is still a good option, okay, but it is really at a mature level. I wouldn't say that it's a complete alternative for Scala, but both the languages will have their own spaces to solve the problem. If we want to really work with hardwares and hardware related issues, solving problem for the high performance, definitely we'll opt for Rust. If we want to really stick with the microservices development with the concurrent and distributed application, definitely will stick with Scala itself, right? So, you might have heard about a lot of companies which are switching from Scala to some other tech stack. I have also heard about a lot of companies which are switching from Python-based microservices to Scala. Okay, so I think a few of my friends which are already migrating their Python-based full stack application to Scala-based application. They are using Akka HTTP for communicating microservices. They are using MongoDB for Mongo for S for MongoDB persistent storage, and they are using front end like React and other things, right? So there are two, three companies that I have experienced that my friends have migrated from Python-based applications to Scala-based, right? So it's just an hype, right? Most of the companies are using Bank of America extensively using these applications. We are also extensively using Scala. Scala is really being matured. A lot of nowadays you wouldn't left with only one library for effectful system. There's a queue, there's a type level, Zero, Akka, and a lot of libraries are each and every day being developed, right? So I would say for Scala, the future is really bright. People are really working hard. They are being paid also high as compared to Rust, if I would say, because Rust has only footprints inside. I would say the applications like blockchain, okay, and these are the spaces where it has not been used where Scala is being used right now. So yeah, for the Scala for 10 plus years, definitely Scala has a special position in market, and I am very hopeful that we'll have a more libraries and support and more system will be developed and utilizing Scala features and language as a whole.
That's true. Like I think this thing always happens that a lot of tech stack like companies migrate from one to another, but just because like
Yeah.
there had been a bit of a buzz around in the market about Scala, so all of this migration has been taken in a bad light, which should not be true. So I think yeah, that's just in the ecosystem that's going. And I think Deepak, you have some question. You want to confirm it?
Yeah, so yeah, hi, Ayush. So
Hi,
yeah,
Deepak.
I do have one question. So you mentioned like you have been using Rust in your project. So as you mentioned, like it is only for REST response, or because what I understand, like you are just integrating your ML framework with Rust, and Rust is just triggering what we can say the ML framework, and what are the response is coming. So the REST integration, I can understand, is being used in Rust. Did you really get any performance improvement over the other REST APIs framework, or what was the reason to use this Rust in your project? Yeah.
In our project, definitely our requirement was to extract the data out of any documentation on fly, pass it to the LLM so that LLM can reason about those texts and find out the relevant fields data that we wanted, and construct a JSON out of it for each and every request, right? So for this scenario, I think Rust has some sort of libraries which were suitable for us to really work upon real-time manner. So we use Actix Web, which is inherently supporting all the kind of features that we wanted, and it also has a seamless integration with Llama index framework. We could also use the Scala based also because Scala based applications are also having supporting the OCR based solution like Tesseract, easy OCR, and OCR for Java, but these were not performant as compared to the Rust-based applications, right? Rust-based libraries. So therefore, we used it. It's just for the OCR purpose. So our purpose is to extract the data, like OCR based application. We used Rust. Otherwise, all the kind of functional domain applications are Scala based, 99%. It's just a kind of use cases where you
Yeah.
want to really solve a
Exactly.
problem. We just get out of the our umbrella.
Even I had worked on one OCR based application where I was using this Python libraries, OCR text extract libraries, as
Yeah,
well as Java also provide OCR library. Okay.
Java for tester.
Yeah, obviously. So yeah, Java, because there's a number of OCR libraries available in Java where we can extract the text from PDF images using the image transformation and other stuff. Yeah. So obviously,
But
yeah,
we
if you have mentioned like yeah, Rust is giving good performance in terms of OCR transformation. So yeah, definitely we will try that one as well.
Yeah, so I would say like it's not about OCR. It's not about text extracting the text, right? Because text can be extracted from images and PDF in Scala itself. It's about doing the real time operation via doing these kind of operations. So let's suppose we wanted to extract the text out of images in PDF. So we used libraries, because when you want to deploy any kind of application solutions in the production, you need to be make sure that you are, even though you're using open source, right, you will have to really do a lot of research and you need to test that particular library. So I tested around 50 to 60 PDF and images, and I got to know that OCR is not at all solution for us, because we want to not only extract the text, we also create out of those kind of text, we want to extract or create a JSON for 6 to 7 fields that we want, right? So let's suppose there are 500 characters in the text, but we are only interested into 6 to 7 key fields, right? For these kind of operation, we got to know that Rust has a native support, or it has a lot of libraries. Communities are really working hard. So for that particular purpose, we use Rust. But we are not using Rust for that. We're also using LLM. So we are using Llama index for constructing the JSON out of text. For extracting the text, we are using Rust-based libraries. For but for creating the JSON out of those fields, we are using Llama index for that. It's an integration of Rust plus LLM frameworks.
Okay,
Yeah.
so tokenization is also giving the in better way,
Yeah.
right?
So we are using
Tokenizing of string. Yeah.
tokenization.
Mm,
We are using prompt. We are giving the we are giving the time frame and all these things. We are integrated that in a low
that's
level.
great. Good to hear. Good to hear.
It's a production based functional financial company, so we never wanted to reach out to chat gpt or cloudy, so we run those application using olama. You might have heard about it, right? So our this solution
Yeah.
is
So
on
model
our
is your custom model, right?
custom model, and it's sitting in our own whole server.
On MSS. Yeah.
Yeah, so that's how we did. That's about it. We are also trying to use Scala's, so we are also having cash flow forecasting ML based solution that we are integrating using Scala based ML solution. Spark ML is something that we are going to use for that kind of, for that kind of use case. I think Scala has a lot of things in the ML space that we are going to use, and I will be keep explore like sharing my thoughts and experiences on this particular thread, so that you guys will be notified what's going on in the ML and LLM space when it comes to Scala. Yeah.
Yeah, like if like you obviously anyone else get some good resource, obviously there's a resource channel in the server
Yeah.
only. Yeah, just share it. So because obviously it would be good for others. Any other
So for all
question?
of you, I also wanted to share one more thing is that I am working on one LLM where I am feeding almost 1,000 books and training it out for Scala use cases. Once it is live, I will be hosting it on my own server, where this particular like ChatGPT like interface will be available for all of you. I'll share the link. That particular LLM will be very performant and solution driven as compared to Scala. Oh, sorry, as compared to ChatGPT, Cloudy, and all the things are available, because LLMs are not maturely behaving when it comes to Scala when solving any problems via LLMs. I'm working on it. Most probably in 15 to 20 days, I think things will be ready for you to utilize, and I'll share the same link here so that you can get the benefit of it also for solving Scala based problems. Yeah.
I think that would be great, yeah.
Yeah, which will be specifically Scala based solutions only. Yeah, so let's see. Hope for the best.
Mm. Yeah, that's honestly that would be great. Yeah, we can obviously conduct a short meeting or short not meeting, short session for you to, explain it better, how you utilize, what did you use. So I think that could be a session of its own. Yeah.
Correct, yeah.
Mm.
So most of the time what happens, like when we work, right? Most of the senior people unable to respond, right? Give the response, or whenever we are getting stuck, the LLMs and internet is not sufficient for us, right?
Mm.
So we
Yeah.
should have a particular, platform where we can just, define our problem and we get the solution, which is easily deployable, not just a solution, but we can
Yeah.
really understand it
Mm.
out and we can just at one go without wasting time, we should be able to get best out of it. What
Mm.
I'm working on
That's
currently.
true. That's true. Like I think everyone can relate with like ChatGPT and all these models don't give correct Scala solution that we seek for. They are
Yeah.
always, talk around the bush. Any, I think any other question? Anyone? I think yeah, that's it. I think it was great having you, Ayush. Like you really talked in layers. You explained different things like which we were seeking answers for all the different backend ecosystem and the why Scala is still